Question 7, got some logarithms. Given that this equals 1, show that x squared minus 16x plus 64 equals 0. I wouldn't worry too much about this for now. We want to be trying to solve this, and hopefully in the process of solving this, we're going to show that. And then we need to solve this bit for the last part B. With log equations, the general rule is that when you've got logs all over the place, log here, you want to use your log laws to collect them together, so you've just got a log in one place, because then if you have, you can rewrite the statement without the log. Now what I mean by that is, if we can collect these using log laws, which we'll do in a minute, then you'll have log to a base, we'll say a base 3, and we'll have something equals, and then we'll have 1 here, or another constant if it was a different question. But what it means then is we can eliminate the logs, because that can be written as 3 to the power of 1 equals that something there. And then you just have a normal equation that you can just solve, which will probably get us to that. So all you need to do is collect these together using log laws. So that's what I'm going to do now. We can do it because the bases are the same. If they're not the same, you have to change the base, and the formula for that is given in the Core 2 formula book. I don't think I've ever seen an exam question where you have to change the base. If I have, there's not been many. So when you're subtracting logs, you divide. But before we do that, we've got a power here. You can only use the log laws if it's log something, log something. Here we've got 2 log something. So we're going to bring that 2 to the front and make it a power. So log 3, x minus 5 all squared, because that's the 2 going there, subtract log 3 of 2x minus 13 equals 1. We're now going to use the log laws, and one of them says that if you've got a log of something, subtract a log of something, as long as the bases are the same, which they are, you can write it as the log with the same base of that thing divided by that thing. X minus 5 all squared divided by 2x minus 13. So we've collected those together using the log laws, and it's equal to 1. Now, like I was saying earlier, we can now get rid of this log, because we can rewrite that, because that says 3 raised to the power of 1 gives you this. So 3 to the power of 1 gives that, over 2x minus 13. And we've just got now, that's just a quadratic equation. We need to tidy it up. Get rid of this bit by multiplying by 3. So to save some space, I'm just going to times that by 3 now. So we'll have 6x, 3 times 2x, minus 3 times 13 is 39. And it's equal to x minus 5 all squared. I'm going to multiply that out now. X minus 5 times x minus 5 is x squared minus 10x plus 25. And this is where we've got a quadratic equation, but we need to have it equal to 0. And hopefully when we do, it'll look like this, or we've done something wrong. Take everything over to the right, because the x squared is positive there. Minus 10x, 6x goes over as minus 6x, so that's minus 16x. 25 plus the 39 gives us that. So we've now shown part A that x squared minus 16x plus 64 equals 0. So I'm going to get rid of all the working out now, and we're going to solve it to do part B. Let's have a... Even if you couldn't do that, you've lost 5 marks, which is a shame, but at least you could do part B still, because it's given you what the equation simplifies to. So hence or otherwise, always do the hence, always do therefore. Solve 2 log or blah 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 blah. So therefore we're not solving this, we're solving x squared minus 16x plus 64 equals 0. And this is dead easy for 2 marks even. Goodness. So part B, we're solving this thing here. So we're going to factorize it. X and x, 64. 8 times 8 will give you 64, and minus will give you minus 16x. So therefore x equals 8. Done. Easy peasy.